Are you getting my voice? My voice is lagging. Okay. Is it fine now?
Yes, sir.
Okay. So today's lecture is very, very important. Okay. Actually, I have given the assignment, and this question is from the second chapter. So I am just deleting this, and we will solve this question. Okay? So see here. Uh, have
So
you
we
done
have
this?
to so we have to
Yeah.
find the electric flux formula, put that, and you told how to add it and that way.
Yeah. We will apply this formula. This phi is equal to E dot A. Phi is equal to E dot A. We will apply this
Yeah.
formula, and I have told you how to find the dot
Multiply
product
it. Yeah. Dot product.
multiplying.
Multiply
Yeah,
the same with alphabet.
yeah. Very good, very good. So see here now. This is the answer of the question. Electric field is given to us. Okay, electric field is given to us 4I cap 4J cap plus 4K cap 4K cap. And ds here, ds means the area vector is given to us. ds is given to us. Ds means the area vector is given 5I. Ds is area vector. This is elemental area vector, you can say, and we have the formula of phi. E dot ds. E dot ds. Actually, we have the formula this. E dot a. We have this formula, no? I have used this formula
Yeah.
here.
Yes, sir.
Area. This is area, but they have given us the area in this form. So we will write the formula like this. We can also write the formula like this.
EA we have done EA cos theta. I think.
Yeah. You can write in the form of theta also, but I am solving this like this. So here dot product we will take 4I cap plus 4J cap plus 4K cap dot of 5I cap. So simply what you have to do, you have to just multiply this 4 with 5 only, and you will get the answer. 20 volt into meter. This is the answer. Why I have done this? Because there here in this part there is no J and K. There is no J and K. I have told you multiply this term, I term with this term. I term means
Area vector.
means area vector. Like here you can see we have multiplied na here. I have told you multiply this. Here is one nothing 1 and 2, 2, 2 and 3 means I cap with I cap, J cap with J cap, K cap with K cap. You have to multiply like this in the dot product. So there is one more question we will solve, and that question is very good question. So see here, The question is very, very good question. Okay, fine. So the question is, we have to calculate electric flux through area of 3 meter square, area of 3 meter square, area of 3 meter square in xy plane, in xy plane. Thank you. In xy plane. Mhm. In xy plane, an electric field is given to us. Electric field vector is given to us like I cap plus j cap 2j cap plus 3k cap, and the unit of electric field is volt divided by meter. This is given to us and we have to find this. And we have this formula. We have two formulas of electric flux. Phi is given to as either by this,
EA cos theta.
either I can write like this or either I can write EA cos theta. You are right. EA cos
Yeah.
theta. So here we do not have the theta, so we will use this formula. We will use, and now see how we will use this formula. They are saying 3 meter square area in xy plane. So if
It's the perpendicular direction.
yeah, very good. If this is y axis, if this is uh, x axis, so there is an area in this. This is the area. We have the area. We have the area in xy plane, and this area is 2 meter square. And we want to find the area vector. We have to find the area vector. This is what is this? This is area vector here. This is area vector. So for this area, we will calculate the area vector. And this is the z direction. So direction of this xy plane area vector in the z direction perpendicular to this.
Yes.
Yeah. And in the z direction, I have told you the vector is represented by k cap vector.
Yes.
In this direction, we have I cap vector. In this direction, we have
J.
j cap vector. Okay. So the area vector, if you want to write area in terms of vector, so I have told you, write the magnitude of the vector first, that is 2, and the unit vector in the direction of that vector. The direction of area vector is in this direction, and in this direction unit vector is k vector. So area vector we have got now. Okay, here is 3 meter square. So this is 3 meter square, no problem, we can change it. Now this is 3. Now apply the formula. Apply the formula. We have electric field. This electric field we have I 2 3 1 2 3. We have electric field I cap 2 j cap plus 3 k cap, and we have area vector as 3 k cap. Now if you want to find the phi, So you will apply this formula E vector dot A vector, and for dot product what you will do, you will just multiply this K with K wale, K with K.
Yeah, because the other values are not right.
Other values will become 0 when you will do this. 3 3s
Yeah.
and 9 is the answer. Volt.
Meter.
The important thing here is to calculate the area vector. Here area is given. This is the magnitude of area, and direction of area is z axis because the area is in x and y axis. The area lies in x and y axis, and we have discussed the direction of xy plane is z axis. Z axis. So you can note it down. The concept here is to find the area. Hmm, 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 hmm. Otherwise, all the things are known, but we have to just little bit find the how the area vector will be calculated here. Area is given as 3 meter square in xy plane, and the direction of area in xy plane will be along the z axis, and the unit vector along the z axis I have already told you is k cap. So that is why I have written here 3 k cap. Written, Bhumi?
Yes, sir.
Okay. So today's lecture is very, very important. I am just saying it again. As we are on the end of chapter. So now see here. We have surfaces. We have surfaces. Surfaces can be plane surfaces. I will give you the example also. Or surfaces can be curved surfaces. Curved surfaces. Like if you have a square, if you have a square, if you have a disc, this is square, this is disc. Square is a plane surface, two-dimensional surface. Square is a two-dimensional surface. Disc is also a two-dimensional surface, plane surface, plane, and the curved surfaces are sphere. Sphere is a curved surface. Cylinder, cylinder also a curved surface. See here, the cylinder, we made cylinder like this. This is cylinder. So cylinder is a three-dimensional. This is cylinder. You can imagine this as cylinder. This is having a length L. This is having a length L, and area of cross section is this. This is the area of cross section. This is a cylinder. So this cylinder is curved surface. It's having a length L and area of cross section.
So even a cone can be a curved surface, right?
Of course, you are right. Very good. You can take the example of cone. Cone is like this. Cone is also a curved surface. This is cone. Like this. Cone is like this. So this is the height of the cone. You can take. And this is the area of cross section of base of cone. You have to identify the plane surfaces and the curved surfaces. You have to identify. In the for
Curved ones are mostly like dimensional, so it's easy to remember.
Yeah. So mm, if you have the area like this, you have the area like this, and the electric field lines are like this. Electric field lines are like this. These are the electric field lines, and this is the area. This is plane area. This is plane area, and these are the electric field lines. Okay, these are the electric field lines will be like this. And if you want to find the area vector, then area vector will be like this. The direction of area vector will be perpendicular to this. This is the area vector.
Yes.
We have discussed this earlier also, but if you have a sphere, or you can say a curved surface, if you have a sphere, or you should be careful here for finding the area vector. Suppose if you have a surface like this, curved surface if you have, and this surface has, as this is a circle, so this surface have some center also. So if you want to find the area vector here, so you will join, you cannot like this, you cannot say that the area vector of this is this. This will be wrong. You have to take the area vector from the center. So how you will do this? This will be the area vector, direction of area vector I am taking. This will be direction, this will be the area vector, direction of area vector. If someone is asking area vector here, so the direction of area vector is in this direction. This is the center O. If someone is asking the area vector here, then the direction of area vector is here. But see here, the direction of area vector is same throughout. Same or not?
Yes, sir.
Here the direction of area vector is same in this direction, but on the curved surface, the direction of area vector is changing. This is curved surface. Here you can see the direction of area vector is changing. Here you can see that direction of A vector means area vector changing with position. You are changing the position, and here plane surface, area vector not changing, or you can say it will remain same. So very important concept this is. Note it down. You have to remember all these things as we will solve some questions there. These things will be used. And electric flux is one of the most important topic of the electrostatics. These are curved surfaces, FACES. Okay, I have written this wrong. You can correct it. This is the discussion about the surfaces. We have two types of surfaces, either the curved surfaces or the plane surfaces. Plane surfaces like square, the plane surface. Disc is a plane surface, but curved surfaces are like cone, cylinder, sphere. They are curved like this. Bhumi, cube. Do you know cube? Cube will be a curved
Yes, sir.
surface. Cube will be a curved surface or plane surface.
So I think
Hmm?
so it's three dimensional. I think curved, but again,
No,
I think it's
actually,
plain also. I don't know.
okay. I am just trying. Then you can tell. Cube is like this. So this is three dimension. You are right. But see here, this is plane surface. Okay. So this is cube.
Yes, sir.
This is plane surface. All the surfaces of cube are plane. So cube is a plane surface, but this is three dimension. Generally, the three dimension surfaces are okay. Surface. Written?
Yes, sir.
Okay. This also written?
Yes, sir. So
Okay.
you said like three dimensionals are mostly not all, but their three dimensionals are curved, but like cube is like exception because all the surfaces are plane over
Yeah.
it.
Here you can see all the surfaces are plane. This surface, this face, or the surface is plane. This is plane. So that is why this is a plane surface. And there are many other surfaces other than the cylinder and this cone. Okay. So
So a pyramid will also be plane then.
uh, a pyramid. Of course, you can say the pyramid is a plane surface. Pyramid is also a plane surface. Okay, means you have understood?
Yes, sir.
Yeah, and we will use all these things. Now we will discuss about the electric field again. Electric field, and there are two types. There can be two types of electric field, either uniform electric field or non-uniform electric field. Non-uniform, non-uniform, and V represents the uniform electric field like this. Uh, just a rough diagram. This is just a rough diagram. And non-uniform electric field is like this, like this, like this. Okay. The representation of uniform electric field, representation of non-uniform. Here in the uniform electric field, you will see both electric field is a vector quantity, we all know. Here you will see the direction as well as the magnitude will remain same. See, the direction of electric field is same in this direction. So you can say direction and magnitude, always the value of electric field at any point will be same. Direction and magnitude will remain same. But in this case, see, the direction is changing. See, here direction is at this point, the direction is this. At this point, the direction is in this
So
direction.
it's not the same
So
in that.
yeah, so direction and also the magnitude will also, when you will move from this point to this point to this point, the value of electric field will decrease. Okay, direction and magnitude will not same. Okay, we have studied this thing. We have studied this thing. Phi is equal to, we have just calculated, phi is equal to E vector dot A vector. E vector dot A vector. But this is valid. This is very important point. This is valid, means this formula is valid for only either the surface should be plane surface, plus the electric field will be uniform electric field. Uniform electric. You can only apply this formula if you have a plane surface and uniform electric field. And see here, in these questions, in all these questions, we have this plane surface, and this constant electric field. This is 5i is also again a plane surface and constant electric field. This is a plane surface and constant electric field. This is a plane surface, A area is constant and electric field is again constant. See here, plane surface and electric field is constant, means electric field is not changing and area was plane. That is why we have used this formula. That is why.
And so the other formula is used for the other two.
Yeah. Now, if the electric field will be non-uniform, or the area vector is changing, means area vector is not like the plane area. If the area will be not plane, then we will use some different formula. So I am just writing when we have non-uniform electric field, non-uniform means changing in direction and magnitude. Non-uniform electric field, and or you can say, if you have either you have electric field non-uniform, or either you have Curved surface. Curved surface means if you want to calculate the electric flux through cylinder, through sphere, through cone, and all that, you will not use this formula or curved surface. So you will use this formula. You will use this formula. Phi is equal to, this is integration. This is integration E vector dot ds vector. E vector dot ds vector. And do you have any idea about the integration? Have you heard the name integration, Bhumi? Because we will use integration here. So
Yes, sir.
integration, yeah, integration is like differentiation. So this is the integration here, and this type of integration is known as the surface integration. Because why surface integration? Because the electric field lines are just crossing the surface. So this is surface integration. We will discuss this now. When the surface is closed, when the surface is closed, like sphere is a closed surface, and if I am giving you the two example, we have a hollow sphere. Okay, we have a hollow sphere, and I have just cut the hollow sphere. This is the hollow sphere, and I have just cut this sphere from here. So the remaining surface will be closed surface or open surface.
Open.
Very good, very good. So means you know what is closed and open. So when you have, when
It's just like
surface,
closed and open circuit.
yeah, when surface is closed, like sphere, or there is one more closed surface, cylinder, there is one more closed surface, cone, etc. So you will use this. This will some little bit changing. I will do some changes in this. So there is, here is this like this, and actually this is higher mathematics. This is not the 12th class mathematics. It's higher mathematics, but we will just have to study the introduction of this. And this thing is used for closed surfaces. I am giving one example. So what is surface integral? I have told you this is surface integral. Now I will tell you what is surface integral and how we will calculate it. Surface integral. Surface integral. If you want to do the surface integral of sphere, for the sphere, we have a sphere. We have a sphere. This we have this sphere. We have this sphere, and sphere is like this. Like this means you can imagine the sphere, like ball, like football is a sphere.
Yes, sir.
Yeah, you can. You have to actually in this topic, the electric flux, your imagination is very, very important. You have to imagine the things in your mind. So I am saying this is the sphere, so you can imagine a sphere. And there is a surface of the sphere also. So this is the center of the sphere. There is a surface of the sphere. This is a small surface of the sphere. This is just the small surface of the sphere. And this small surface have a small surface area, ds. This is the surface of the sphere. I am taking just the small part of this, the
which is
surface.
called DS.
Yeah, which is known as ds. Which is known as ds. I have already told you. I think I have not told you. Wait. So ds is for small surface area. So if you want to calculate the whole surface area of this, means surface integration of this will be this is like this, and if ds is written like this, means the meaning of this, the surface area of this sphere, meaning of this is the surface area of sphere. Surface area of sphere. And please remember that integration is the area. Integration gives the area of figures. Okay, integration gives the area of figures. If you have I think you are a medical student, I think so, you don't know about this. If you have a mathematics, then you have a chapter application of integral in 12th class. There you will calculate the area of the curves with the help of integration, but I am not going in detail. Just remember this surface area of the sphere, and this term is equal to, if some is written like this, so you will write what you will write. You will write 4 pi r square. Simply, r is the radius of this, and this is ds. Ds is the small area. Okay. Now cylinder. Another thing. We have cylinder now. Second number is cylinder. You can imagine this as cylinder, this thing. This as cylinder. Now you should actually see here. This is the cylinder. See, this is the cylinder, and see the curved surface of the cylinder is this part. Are you getting or not? Means you have to imagine this.
Yes, sir.
The curved part, curved surface area of the cylinder is this part, this, not this. This is the plane area of the cylinder. This is the plane area of the cylinder. This part of the cylinder is the curved area. So for the cylinder, if I am taking this cylinder, actually you have to imagine all these things in your mind in 3 dimensions. So curved surface will be this part is the curved surface, this part, this upper part, not this part. This part is not the curved. This part is plane area. So in the cylinder, we have this part. This is actually a circular area, circular plane area. This will be circular plane area, but this area is curved. Curved surface will be there. This surface is curved surface. This surface is curved surface. This, all the surface, and this surface will also be a curved surface. And this is again a plane surface area, circular plane surface area. Circular plane area. Circular plane area. So if you want to, if you will take a small area on the surface of this is ds, and if you want to calculate the surface integration of this ds, then you will get the surface area of the cylinder, curved surface area of the cylinder. Okay, curved surface area of the cylinder. These points are very, very important. Are you getting this now? This is little bit complex for you.
Yes, sir. The DS is a curved surface area.
Yeah, curved surface.
You can take DS through plane area also, right? So that will be plane.
Of course, I can take ds here. ds is just a small part of area. That can also be of plane, either of curved. Curved. I am just calculating this because we will use this in the question. Curved surface area of cylinder, and that is equal to 2 pi rl. 2 pi r is the radius of the cylinder, l is the length of the cylinder. So this is the l of the radius of the cylinder, and sorry, this is the length and this is the radius. R is for radius, R is here radius, and L is length. L is length. So please revise all the points, take 1 or 2 minutes, and after that we will solve one question. Okay?
Yes, I can note and revise.
Okay, you should want to note it down. Okay. Have you completed this part? This part completed?
Yes, sir.
And you want to write from here, na?
Oh, yes, sir.
Please note it down. After that, we will have a question on this. Actually, all these things are in 3 dimensions, so we have to imagine all these things. This is a sphere.
Oh,
This is
yes, you can
cylinder.
scroll.
Yeah, this is a sphere. Now we will solve one question on this. Very easy question. Completed, Bhumi?
Yes, sir.
Okay, now we will solve one question. Now, see carefully. A charge or you can say this is a point charge. This is a point charge is placed at the center of conducting sphere is placed at the center at the center of a sphere of radius r of radius capital R and the value of this point charge is given as plus q. Okay, a plus q charge we are placing on the center of the sphere of radius r, and we want to find the flux through the surface of the sphere. Calculate flux. Flux means electric flux. Calculate flux through the sphere. So they are saying we have a sphere, and at the center of the sphere we have a charge plus q. We have a sphere. This is the sphere, and at the center we have a plus q charge. At the center we have a plus q charge, and we have to find the electric flux through this sphere. So what we will do, we will take a smaller area ds here. We will take a smaller area ds here, and I have told you, if I want to find the electric field on this surface, see here, the surface is curved here. This surface is curved surface, and at this point the direction of electric field will be in this direction. Bhumi, I have told
Oh,
you
yes,
this.
sir. We'll use the formula
Yeah,
which is like
we
for
will.
the
Yeah,
curved one.
yeah. If here we want to find the direction of electric field will be in this direction, because from this positive charge the electric field will be away from the charge, and we have taken an area ds. We have taken the area ds, and
Yeah.
I have already told
Electric
you.
flux is equal to
Yeah,
EDS.
we will use this formula, but the
Yes.
thing is here is,
With
see here.
integration and vector EDS.
Yeah, yeah. And see here that if you will calculate the direction of area vector, you will draw a straight line like this. Means line from the center to that point. So what you will do, if you want to find the direction of area vector, then what you will do for the direction of the area vector, the direction of area vector will be like this, means in the same direction of area vector will be also in this direction.
Yes.
See, okay, very good. So ds, what is ds? Ds is
The
elemental,
small, yeah,
small,
like
or you can say small, or you can say elemental.
part of.
Yeah, yeah, part of area, elemental area vector, and is the electric field. And see here, the electric field will be constant at all the points. If you will take the area here, then the direction of electric field will be in this direction, Means the direction of electric field is changing at every point. At this
Yes.
point, at point A is like direction of electric field is this. At point B, the direction of electric field is this. And here also the direction of area vector is this. So you can see here the electric field is changing and area vector is changing. So we cannot use this formula. Phi is equal to, we cannot use this formula. E dot A. E
Yeah.
dot A. We cannot use this. We will use phi
The other
is
one.
equal to,
Integration E.
this is closed surface. So we will do like this and we will write E dot ds.
Yes.
Yeah, E dot ds. And one thing more, E dot ds. One thing more, if you will calculate the value of electric field at point A, that is equal to k q y r, if r is the radius here, and electric field at point B you want to calculate, then again you will get k q y r. So the magnitude, this is the magnitude of electric field, this is the magnitude of electric field. Means the magnitude of electric field is not changing, but the direction is changing. See here, the magnitude of electric field is not changing, but the direction is changing. So for this, I want to tell you one thing. You can note it down. This thing.
But it can happen that the direction and magnitude both are changing,
Yeah,
like
yeah,
for some
yeah.
other plane.
Yeah, of course. So if you have a two vectors, vector A dot vector V, and I have told you, you can write this A B into cos theta. We have discussed this here.
Yes. Yeah.
Okay. This is if two vectors are written in this form, in the dot form, so we can write one vector, another vector, and into cos theta. Okay, this form can be written and in this form cos theta, and theta is the angle between the vector, two vectors, angle between two vectors. So now see here. Okay, see here. This is the thing we have. Each and every point of this is very, very crucial. So we have this now. So I can write this like this phi can be written. This is phi, phi phi. So this can be written as E ds into cos theta, and theta is the angle between E into ds. Sorry, E and ds is the angle. So what is the angle between electric field and ds vector here? What is the theta here? Both are in same direction.
Yes.
So theta will be 0 degree. Both are in same direction. Electric field is in this direction and the ds vector also in this direction. So if two things are in same direction, angle between them is 0. Okay. So now we will solve the value of phi. Phi is the flux. Phi is the flux, means total flux through this sphere. So you will write this surface integral E ds cos 0, and value of cos 0. Do you know value of cos 0 degree? That is 1. So we have E ds only 1. This is 1. Cos 0 is 1. When you will multiply 1 here, this
Yes.
will become, this will remain same.
It
So
will get cancelled.
and also one thing more I want to tell you, if something is constant, you can take out of integration. Here electric field is constant, the magnitude of electric field is constant. The magnitude of electric field is constant. EA is equal to EV. That is constant is equal to E. This is same. So you can take this out of integration. E can be written here, and this is ds, and this is phi. And what I have written for this term, for the sphere, I have written something now. You will tell me. See here, for the sphere I have written this 4 pi r square surface area.
Yes, sir.
Okay. So we have phi is equal to, you will put the value of E here. E is kq by r, and this is 4 pi r square. Now what will be cancelled? R and R cancelled out.
GQ into 4 pi.
Yeah. And we have, and the value of k is also known, 1 upon 4 pi
Epsilon naught.
So you can put the value of k here. We have this kq 4 pi r. So put the value of k 4 pi epsilon naught.
So it will get 4 pi will get cancelled.
Yeah. 4 pi r and 4 pi will get cancelled. So you will have qr
by epsilon naught.
qr by epsilon naught. I think, give me just 1 minute. Okay, sorry. The value of formula of electric field is not kqy. This is kqy r square. Okay, kqy r square.
So there will be one r at the end.
R square. Okay, so both will be cancelled out completely. Both will be cancelled out. This r, yeah. This also will be removed from here. So we have the formula of phi. We have phi equal to, this is only q here, and this is epsilon naught. So we got this. See here, what is q? Q is the charge inside, and epsilon naught is the permittivity
constant.
Yeah, and q is the charge. So this is the very good question, and there are multiple concepts in this question. You have
this
to imagine
is like a derivation, right?
Yeah, you have to imagine a lot of things here in 3 dimensions. So you can note it down, and after that we will discuss the Gauss law. From here, na?
Yes, sir.
Yeah.
Gauss's law and the application is the last thing.
Yeah, you are right. Have you studied this chapter already, Bhumi?
Yes, sir.
Okay, very good.
Like a long time ago.
Long time ago means 5 or 6 years later?
No,
Means
I
earlier?
mean months, like 5 months.
Okay, no problem. Who is this? Huh? Okay, there is. I think there. Okay,
Yes, sir, you can scroll.
Okay. Someone is in the waiting room. Actually, our time is up.
Yes, sir. It's 5-2. Over here, I mean, it will be 7:30.
Yeah.
7
Here, you are in India.
No, sir, Qatar. It's 5-2 over here.
Okay. Just wait.
So done.
Okay, just wait for 1 minute. I'm just asking something.